I left this here just to remind myself to mention the movie that we watched at the start of the Zoom on Monday. I'm doing this obviously before Monday. Was intended to help you understand that a function has inputs and outputs. And typically, at least for this year, we'll just focus on the variable x is the input to the function. And then you apply all the operations to that variable, and you find out what y is, and y is the output. Just like the chickens going into the machine and coming out chicken McNuggets, or the different examples that you saw. It's just that's a function is kind of like a machine. There's input and there's output. The part that I didn't probably, or at least I'm not intending to do in the Zoom while we're together, is the explanation of what is a function, because I think that's better accomplished using this video. So thank you for watching the video. I plan to spend our time in the mandatory Zoom doing more practice together and getting an understanding of how to select inputs and calculate outputs. So we skipped right over this part of the notes. If you see a relation of points graphed on a coordinate plane, you can tell whether it's a function by using the vertical line test. You visualize, or you could even draw a vertical line, and then imagine if that vertical line moves from left to right. Think about whether it ever intersects more than one point. If it only ever intersects one point at a time, then it's a function. If it ever intersects more than one point, then it's not a function. So there's sort of like a true, false, yes or no type of question when you look at a graph. And so let me give you a couple examples, and you can write them in your notes. This collection of points, we're trying to determine, is it a function, yes or no? Let's draw a vertical line, which is not easily done in this program, but if you draw a vertical line, you can use a straight edge on your notes, but if you draw a vertical line right here, you see that that line only intersects one blue point. If I draw a vertical line right here, it intersects no points. No points is okay, 1 point is okay. It just can never intersect more than 1 point. We're okay right here, and then you probably already noticed that if we go here, where x equals 1, when x equals 1, y equals 2 and -1. And that's not allowed. So this is not a function. I'll give you a, let me put a, didn't mean to erase our answer though. Answer is no. Imagine that y was temperature. Let's say it's temperature in degrees Fahrenheit. And let's imagine that x, the horizontal axis, the independent variable, is days. Let's say well, first we have to imagine we live somewhere really, really cold. Let's say Alaska. And I decide I'm going to keep track of the temperature in degrees Fahrenheit. Every day I'm going to figure out the average temperature. So the temperature, the dependent variable, depends on which day I check the average temperature. That's the independent variable. So if on day, let's number these days, 1, 2, 3, and let's put some actual temperatures here. 10 be low temperatures because we're talking about Alaska, of course. 20, 30. This is below the x-axis. This would be -10 degrees, -20 degrees, -30 degrees. If we look at day 3 of my computing average temperature, on day 3 the temperature was -30. So if I did a little input-output table here, x, y, where x is the day that I'm checking and y is the temp in degrees Fahrenheit, on let's just do let me think ahead here and do like a little bit bigger table so I can show you a couple other things. But day 1, day 2, day 3, I'm just going to put those down here. On day 3, the temperature is 30 degrees. Okay, fine. The temperature is 30 degrees, positive 30 degrees, pretty cold, but it is Alaska after all. 30 degrees above zero on day 3. On day 2, it looks like I didn't take a temperature readings. I forgot to do my job on day 2. That doesn't mean the answer is 0. There's just no data there. No data. That's fine. So far we're good as far as a function, because on day 3 I have a specific temperature. On day 2 I don't have any temperatures because I forgot to take the temperatures. So far that could be a function. But on day 1, the average temperature was 20 degrees and negative 10 degrees. 20 degrees above 0 and 10 degrees below 0. How could the average temperature be two different temperatures? It's either 20 or it's negative 10. This is why this is not a function. For a specific input, like a specific day that you're calculating, you should only have one average temperature. The 2 points, the two different temperatures, disqualify it as a function. All right. To try to make this like a real-world problem, if I think of this as like the day before I started measuring the temperature, maybe the day before, or on day -1, the day before I started actually doing this experiment, maybe the average temperature was 10 degrees below 0. But there is a specific average temperature for that day. Okay. I wanted to have at least one real-world example. There's another one coming up in a bit. Here we have a line graphed, this blue line, and if I choose to draw a vertical line anywhere, my vertical line only intersects that blue line at a single point. And so as long as I'm not intersecting at 2 points, it's a function. Yes, it is a function. Now, we talked when we did geometry earlier this year about that line is infinitely thin, and so even though it has to have thickness for us to see it on the screen or on your paper, but we know it's infinitely thin, and that's why we know it's only intersecting a single point. If I draw a vertical line right, I can't draw a straight line on this writing tablet, but if I think you see where I'm trying to draw it. If I draw a vertical line right there, I'm only intersecting 1 point. But anywhere else I draw a vertical line, I'm intersecting 2 points. So this is not a function. So you have a few problems on your on tonight's, or I should say tomorrow's learning opportunity, that have you just answer yes or no whether it is or is not a function, so you can use the vertical line test to check that.